maximum, minimum stuff, and graphing is really where we're going in this chapter. So we already know a little bit. We've done some optimization things, like if I ask you to find the highest or lowest point, what are we looking for?
Maximum, minimum.
And how do we find maximums and minimums? Set the derivative to 0. Now this has a lot of applications. You know, if you think about manufacturing, you want to make a certain shape of a can that would minimize your cost, right? That seems legit. We would want to make our costs as small as possible. You know, if we think about any kind of business, you want to maximize your profits. Okay, if we want to talk about NASA, you want to maximize acceleration. There's medical aspects. You want to look at what rays of a contracted windpipe would expel the air most rapidly during a cough. Angles of blood vessels. There are lots and lots of applications. So this maximization and minimization is kind of why calculus is required for so many different things. We are going to be focusing on how this applies to graphs in here. So back in college algebra, pre-calculus, we talked about local maxes and mins and absolute maxes and mins. When I'm talking about an absolute or a global, that means it's the highest or lowest on the entire graph. So it's higher than every other point or lower than every other point. Looking at this particular graph, we can see we have an absolute max where, because this point is the highest on the entire graph. You can write it, if you're looking in the book, they always do it as ordered pairs, so they'll say like f of 3 equals 5. We can do them as, like, I don't use function notation as much, most of the time I just write the ordered pair. So we can do any of those things. We have an absolute minimum right here, so that would be the point 6, 2, or you can say f of 6 equals 2. They can be called global or absolute. If I ask you to find extreme values, that's saying find all the maxes and mins. One thing about these, they can be endpoints. Come on. Okay, so if I'm asking you to find the maximum on the entire graph, we're not just looking at the center of the graph, we have to look at the ends as well. Then we have local maxes and mins. So local maxes and mins don't have to be the highest or lowest on the entire graph. They just have to be higher or lower than the surrounding points. So if I look at this particular graph, okay, is this the highest on the entire graph? No, but it's higher than the points on either side of it. So that is called a local max. What would this one be?
Absolute.
It is the absolute. And it would also qualify as a local max. So this one is both absolute and local. What about at point C here? What would this be? Local min. E would be another local min. At point A, this is the lowest on the entire graph. It is an absolute min, but not a local min. Local maxes and mins cannot be at the endpoints. So the absolute or the highest and lowest on the entire graph, that could be an endpoint, but if I'm just talking about local, we don't include endpoints in that. So far, so good? Abigail, are you all right?
Thank you.
You're welcome. All right, so let's take a look at an example. If I said we were looking at x squared, we know, what does x squared look like? Parabola. Okay, does it have any maximums or minimums? Yeah, where? 0, 0. What is that? Max, min, local, global? What'd you say? Global min, and since it's not an endpoint, it would also be local. So it's global or absolute and local min at 0, 0. We could get that from the graph just by looking at that point. What about if I said x cubed? What does x cubed look like? A chair. All right, if I'm looking at this, do we have any maximums or minimums on this? No. Okay, so a graph is not required to have them. It may, but it doesn't have to have all, and it may not have anything on it. All right, let's take a look at a graph, and I apologize, the quality on here is not great because I was trying to steal it out of a book and not recreate it myself. So I apologize, I was being lazy. If I'm looking at this, so do we have any absolute max? Do I have a highest on my entire graph? Okay. Absolute min, do I have a lowest on the entire graph? This is the lowest, but what's different about that? It's an open circle. So can you tell me the closest thing to that open circle? No. So if it ends with an open circle, that doesn't count. There is no absolute min because my lowest is open here. All right, local max. All right, the locals can't be endpoints. So we're looking for points that are higher or lower than surrounding points. So here's a little peak, but again, that's an open circle, so does it count? No. All right, let's look right here. This is closed and that's open. So this one, is it higher than the points on both sides of it? Yeah. Yes. So that would be a max at 0, -1. Okay, this right here is open, so it's not going to be anything. Then I have a closed. Is this one higher than the points on both sides of it? No, so it's not anything. Would my absolute max also be a local max? Yes, because it's not an endpoint. Okay, local min. Again, no endpoints. We want something that is lower than all the surrounding points. So that was an open circle, but look, it's got a closed circle right underneath it. Is this closed circle lower than the points on either side of it? Yes, so that is a min. So -4, -2 is a min. What other local min would we have? -3. Anything else? I think that's it. At 0, this one is open, so it can't be anything. So that's all we've got. All right. Let's practice drawing a graph that meets some requirements. So I'm giving us a list of requirements, and we have to make a graph that would fit. I didn't give you tons of information here, so I didn't give you necessarily like all exact points. I know I have to have an absolute max at 5. So that's saying when my x is 5, my graph has to be the highest it ever gets. So I didn't tell you what the y value was, so I'm just going to put 1 point fairly high up there. That is my highest. An absolute min at 2. So when x is 2, that is the lowest my graph can ever get. Maybe I should. I'm going to make my max red. And I'll make my min green. Just kind of help visualize this. Okay, a local max at 3. So when x equals 3, I need a local. So it can't be the highest on the whole graph, but it's higher than those around it. So maybe it's up here. Local min at 2 and 4. So I already have 2 as an absolute min. because it's local, what do I know that 2 cannot be? It can't be an endpoint. And 4 is also a local min. It can be hard just to read this and try to draw your graph. So I always try to sketch it out and then go back and reread my requirements afterwards and make sure it matches. So I know this is my min. Okay, we have to come back. This has to be a max, a min. And this one, that was a max, right? So I've got to turn around and come back down. And I don't want to keep going down forever. What would happen if I put an arrow on this? Yeah, it would keep going down, and then would this be an absolute min anymore? No. So you don't want to end with an arrow if you have absolute maxes or mins. Just make it a point that we end at. So then let's run through and check. Do we have a highest point when x is 5? Absolute lowest point when x is 2? A local max at 3, local max or local min at 2 and 4. Do we need our requirements? Yeah. There are different options for how to draw it. We just kind of guess here. So you just have to make sure that your graph works with what we're given. All right. So let's keep going through things. This extreme value theorem tells us if a function is continuous, then it has a max and a min somewhere in the interval. Okay, you notice it has to be continuous on a closed interval, so a definite starting and stopping, so that prevents something from going up or down forever because we have starting and stopping. So if you guarantee to start and stop somewhere and there's no breaks in your graph, you have to have a highest and lowest point. Here's just a few scenarios. So since we have definite starting and ending, we can't have arrows, so we can see here's the highest, here's the lowest. The highest, lowest. These two are tied for highest, and that's the lowest. So we agree with that? Seems reasonable. It doesn't work if you have a break in your graph. Would I have an absolute max in this one? No, because it's an open circle, and I told you open circles can't count for anything. This one doesn't have a definite ending point. It ends at a vertical asymptote. So those are some scenarios that would cause us to not have maxes and mins. Now we've already kind of mentioned, how do we find a max and min if it's one of our nice points like these? If you draw your tangent line at any of those points as horizontal, and if you have a horizontal tangent line, that means the derivative is 0. So this is our big thing for today. If you have a local max or min, the derivative is 0 there. Okay, so then here's a question. If the derivative is 0, does that mean it has to be a maximum or a minimum? So is it possible to have a horizontal tangent line without a maximum or minimum? Seems like we should have one, doesn't it? Okay, think about x cubed. We already agreed that one didn't have any maxes or mins, right? So if I did the derivative, what's the derivative of x cubed?
3.
If you set that equal to 0, divide by 3 and square root, you get x equals 0. It's saying we have a horizontal tangent line at 0, but was it a maximum or a minimum? No. So when the derivative is 0, doesn't guarantee we have a max or min, but if it's a max or min on a continuous function, then the derivative is for sure 0 there. So here's what we're going to do to start finding maxes and mins. We are going to find derivatives, find where they're 0, and then we're going to test our points to see what is and is not the max or min. I gave you another scenario here where we could get a maximum or a minimum. Absolute value function. Remember back when we talked about derivatives, I told you the derivative doesn't exist at sharp corners because we can't draw just one tangent line there. So this derivative actually doesn't exist at 0, but would we agree that that was a minimum? Yeah. So there's a second place where we could get a maximum and minimum. It's where the derivative does not exist. So we are going to go through and find critical numbers. Critical number is anywhere the derivative is 0 or does not exist. And those critical numbers are the numbers that could be a maximum or a minimum. They are not guaranteed, but they could be. So we'll find our list of critical numbers, and then we'll see from that list which ones are in fact maxes and mins. So let's do a problem. So I want to find my critical numbers here. We know to do that we're going to have to do a derivative. What would we probably want to do before we did this derivative? Do you guys want to do product rule? No, so let's multiply it out first. It'll be 4x to the 3/5 minus, this is an x to the first, so like 5 over 5 plus 3 over 5 will be 8 over 5. So then the derivative. Exponent comes down. So 4 times 3/5 is 12 fifths. X, what's 3/5 minus 1? Minus 8 fifths x to the Alright. How would I go about finding any critical numbers from this? You guys have thoughts? It's kind of ugly, isn't it? Okay, what would happen if I pulled out, what if I just took out the 1/5 so we didn't have a fraction? And when we factor out variables, we always factor out the smaller power, right? What's smaller, -2/5 or 3/5? So if I take that out, I would have a 12 left in the first term, minus 8, okay, in this term. When you factor, you're subtracting exponents, right? So what would be 3/5 minus -2/5? 5/5, or just 1.
How did you get 12?
Okay, I took out the 1/5, so that took out the denominator, and I took out all my x's.
Oh, okay, it just takes it out.
Yeah. I was just trying to clean it up so it's a little
I
easier.
guess
Okay.
maybe I thought you had to minus it. Okay.
Well, okay, if you do subtract your exponents, -2/5 minus -2/5 gives you a 0.
No, I thought you like subtracted the 12
Oh,
minus the
gotcha. It's like dividing.
Got it.
All right. Hello. No basketball
No,
today?
we're gonna leave them there. so.
Okay. Sounds good. All right. So then we need to know when this derivative would be 0 or undefined. Okay. What does a negative exponent mean?
Bottom.
Okay. So we would just multiply this over and it would go away, right? So asking when this is equal to 0 is really just saying when does 12 minus 8x equal 0. Divide by 8, so 12 over 8 would reduce to 3/2. So at 3/2, my derivative equals 0. Oh, we have another critical point. Does anyone know what it is? Why? If we put in a 0 here, what happens? Can you do 1 divided by 0? No, it's undefined there. So because this is undefined at x equals 0. My critical points, or critical numbers, whatever you want to call them, usually I'm just going to abbreviate that as CP, are at 0 and 3/2. That was probably not the nicest problem to start you with. I thought, polynomials are going to be much nicer, but I wanted to show you how you could get something that was undefined. So when you have negative exponents, when we have fractions, that's when we need to worry about those extra critical points, when a denominator could be 0. All right. Oh, you'd be amazed. All right, so I want to find our absolute maxes and mins. Here's what we're going to do. We find all the critical numbers. We're also going to take our endpoints, because in order to have an absolute, we have to have our endpoints there. And we will plug all those critical numbers and endpoints back into the original to see which one gives us the largest number. So let's do this with a polynomial, something nice and pretty that we can wrap our minds around. How do I find my critical points? Derivative. If you don't know the answer to something I'm asking, the answer is probably derivative.
Yeah, it's kind of like how in church it's either Moses or Jesus.
Can't talk to the line. Can't talk to the line.
All right, so my derivative is 3x squared minus 6x. And then, what would we do? When we find critical points, we take the derivative and set it equal to 0. So what could I factor out of this? That leaves me with x minus 2 equals 0. So my critical points are 0 and 2. All right, I gave you an interval. Double check, are both of these critical points in my interval? Yes. If I got like 10 or something that wasn't in my interval, I just wouldn't use it. Okay? Now I'm going to test my endpoints and my critical points to see one of these has to be the biggest and one of them has to be the smallest. I need to figure out which is which. So I'm plugging all 4 of these numbers into the original function, which is where the basic calculator piece might come in later on. All right, so if I put in a negative 1/2. All right,
I'm getting there.
you got that one?
Just give me a minute.
Corbin, you do 0. Logan, do 2.
What was
Bell, do 4. Ben, double check the negative
Wait,
1/2.
what am I doing?
Negative 1/2.
Put it into what?
The original. So everybody check your. Were you my 2 person? Alright. That was
17.
okay. What did my negative 1/2 people get?
Yeah.
Alright, so what is the absolute min?
2.
2 negative 3 is my absolute min. You can write it as an order pair, or if you just want to label it right here, that's fine. What's my absolute max?
Or 17.
There we go. That is how we find an absolute maximum.
Huh. Interesting. I don't hate this.
Good, good. I like it.
It's satisfying. Now, this other stuff, I don't know about that.
Oh,
Something I was lost
you guys
on.
have so little faith in me.
No, we're good.
Our conference script.
I'm being lost somewhere.
Alright, let's look at this one. I want to know, do I have a maximum and minimum on the interval 0 less than or equal to x less than 1? What do you notice about this, first of all? There's an open circle. It ends with an open circle. So am I going to have both a max and a min?
No.
Probably not. Alright, let's see. To find it, we need critical points. How do I get my critical points?
Derivative.
What is my derivative?
2.
Okay, points are when the derivative is 0. Does that ever equal 0?
No.
So there are no critical points. That means my only options for the max and min are the endpoints. But do I really even have 2 endpoints? No. If I put in 0, I get 0. If I put in 1, I get 2. But what this is saying on my graph, 0, 0 is an actual point, but 1, 2 would have been an open circle. So because this is open, that means there is no actual max. What would 0, 0 be?
And your attention, please.
Min.
We will be practicing the earthquake drill. You'll practice by getting under your desk.
6, 31, and 37. So 3 through 6 are looking at graphs and telling me the maxes and mins from the graph itself. 31 and 37 are just finding critical points. You don't have to find the maxes and mins yet. We're going to practice more of those tomorrow. So just a couple with looking at graphs and a couple finding maxes and mins. Or sorry,
What's
finding
the
critical
catch?
points. There is no catch. I'm a nice person.
This is 5 problems.